Hi kids, today our topic of discussion is Pythagoras Theorem from class 9. Now before we start this theorem, I need to tell you a small story. Story about this gentleman, Baudhayana. First of all, he was born around 800 BC, which is actually, if you calculate, 1000 years before Pythagoras was born. And he was a great, renowned Indian mathematician. Now he gave this. I'll just read it. The diagonal of a rectangle produces by itself the same area as produced by its both sides. Which means, if you can decode this, if you have a rectangle, okay, suppose this is the diagonal, this side is A, this is B, and this is C. The diagonal of an area produces by itself, which means you are multiplying diagonal with itself. Which means if you multiply C with C, the size of the diagonal I've taken as C, you'll get the area of a square, isn't it? So what do we get out of this part? I'll get a area of a square of side C. See, again, the diagonal of a rectangle produces by itself the same area as produced by its both sides, which means if B is multiplied to itself, we get area of this square as B square. Again, if we make another square of side A, we multiply A with A, we get A square. And according to Baudhayana, okay, C square is equal to A square plus B square. And this is what is regarded as the modern Pythagoras theorem. Now the question arises, why is Baudhayana's theorem ignored? Because at that time, the Greek philosopher and the Greek mathematician, they believed that Baudhayana gave this theorem, the Pythagoras theorem, today's Pythagoras theorem, he proved it by the concept of area. He did not do it by the concept of geometry, which is again a wrong statement, I should say, because Baudhayana did it by both area and as well as geometry. But still it was ignored. So actually the credit for Pythagoras theorem goes to our Baudhayana. Nevertheless, now let's get into Pythagoras theorem. Okay, let us prove Pythagoras theorem. Now let us see the Pythagoras theorem. What he says, in a right angle triangle, the square of the hypotenuse, we know the side opposite to 90 degrees is your hypotenuse, is equal to the sum of the squares of the other two sides. So in this diagram, if you take A, B, C, okay, AC as the hypotenuse, then AC square, we can say that AC square is equal to AB square plus BC square, which I have written. I have taken AC as small a, AB as small b, and BC as small c. So A square equals to B square plus C square. Now let us prove this. Let us see how we can prove this theorem. Now look carefully. I am taking a right angle triangle. Okay, side A, B, C. Now there's a construction. What I'll do, suppose A, B, C. I'll extend BC to D in such a manner that CD is equal to the length of AB, which is B. Okay. Now at D, I'll draw a perpendicular, suppose DE, which is equal to BC, side C. Okay, then what I'll do, I'll join EC, okay, and this is your, now look carefully. Now if you look at triangle ABC, in triangle ABC and triangle DCE, DCE. If you look carefully, AB is equal to CD. Angle ABC is equal to angle CDE. Then BC is equal to DE, isn't it? Which means these two triangles are congruent. Can I write triangle ABC? Triangle ABC is congruent to triangle CDE. Congruent to triangle CDE. Now look carefully. If these two triangles are congruent, definitely AC and CE will be same, which means if this is A, this is A. And look carefully. If I take this angle as X, this angle as Y, then since these two triangles are congruent, you can say angle A and angle C will be same, which means if this is X, this has to be X, CPCT. If this is Y, this has to be Y, CPCT. Okay, this is side angle side. Now just look over here. In this triangle ABC, X plus Y plus 90 equals to 180, which means X plus Y equals to 90. Now look at this angle, suppose Z. Now X plus Y plus Z, actually we have proved that X plus Y is 90. And since it's a straight line, we can say that X plus Y plus Z equals to 180. X plus Y is 90, which means Z will be 180 minus 90, which means Z equals to 90 degree. Which means now we have three right angle triangle, ABC, CDE and ACE. And if you combine all the three right angle triangle, you are getting a trapezium ABDE, whose parallel sides are B and C, and whose perpendicular distance is B plus C. Now look carefully, we'll try to find the area. Just look here. Area of trapezium will be definitely equal to area of ABC plus area of CDE plus area of ACE Now area of trapezium, we know the formula, half into sum of parallel side. Now I told you AB and ED are parallel, which is P plus C, into perpendicular distance between them, which is again B plus C. If you look at the diagram, okay, these are small, okay, these are capital, don't get confused. Okay, area of triangle ABC is half into base into height, which means half into base into height. Sorry, half into base is what? Base is C and height is B, plus area of CDE, again half into base into height. Area of ACE, half into base, which is A, and height is also A. Am I clear? Now look carefully. Now half taken common, so half goes away. Okay, now B plus C into B plus C is B square plus twice BC plus C square. Over here BC plus BC plus A square, which means twice BC cancels out, which means B square plus C square is equal to A square. And if you look carefully, the hypotenuse was A and the other two sides were B and C. So the square of the hypotenuse is equal to the sum of the squares of the other two sides of a right angle triangle, and that's the Pythagoras theorem. Okay, now let us see the converse of this theorem. The converse statement, which means in a triangle, if square of one side is equal to the sum of the squares of the other two sides of a triangle, then the angle opposite to the first side is a right angle triangle. That's a converse. Okay. Now let us see how can we prove this. Okay. Now this is a triangle I've taken ABC, and I've taken that this is known to us. Okay, that BC square is equal to AB square plus AC square. We need to prove that this angle is 90 degree. How can we do that? Let's construct another triangle PQR in such a fashion that PQ, construct a triangle PQR such that PQ is equal to AB, okay, then PR is equal to AC, okay, and angle P is equal to 90 degree. We are constructing a triangle like this, okay. Then now in this triangle, for this triangle whose PQ is equal to AB, RP is equal to AC, we have constructed the triangle in such a manner, okay. Now look carefully. In this triangle, by the use of Pythagoras theorem, I can tell that RQ square is equal to RP square plus PQ square. Can I tell or not? Definitely. And in this, I already know that BC square is equal to AB square plus AC square. Now look carefully. Again this statement. RQ square is equal to RP. Now instead of RP I can write AC square plus PQ. Instead of PQ I can write AB square, which is RQ square is equal to AC square plus AB square, which definitely means RQ square is equal to BC square. Since the square are equal, we can say that RQ is equal to BC, which means this side and this side are same, which means now these two triangles you can say are congruent side, which means I can say triangle ABC is congruent to triangle PQR by side axiom. Am I correct or not? Now if these two triangles are congruent, then angle A and angle P will be equal, which means if this is 90 degree, this has to be 90 degree, which implies angle RPQ is equal to angle CAB is equal to 90 degree, CPCT. Proof, which means this angle is 90 degree. Okay, so this was the converse of midpoint theorem. So in this video, keep it till here. In the next video, we'll solve sums from the exercise. Till then, take care.